addition sign, that is plus symbol, is what connects the element, this first element as well as the second element. So in order to be able to do that, so what I will do is to rewrite this thing as x plus, then I will say minus y. So then I can now put my power here. So since I'm having other form of brackets here, there is a need for me to use other form of bracket. Then that shows if this one is a round bracket, then I can make use of a square bracket or any other form of bracket of one's choice. But where I'm going in essence is when one of the number happens to be positive and the second is negative, we can rewrite it, that is, we can re-express it in this pattern. And we know quite all right that when we try to open these brackets, right, the result this thing will give is the same question which we have here. So which means when we have a question involving negative sign, right, then this is the way to adjust it. So let's work on an assumption that this principle of expansion covers only for addition, right? That is, it's supposed to be in situation of first number being positive and plus whatever the second number may be. So that's the principle by which we want to do this thing. So we can see this presentation is for secondary school students. And now one of the best way to make sure they fully grasp and understand this thing very well, because I want a case or situation whereby in the process of us dealing with advanced mathematics, we are doing it in a natural way. So it's only when we are doing it in a way which is natural to them that would make it making any sense to them. Otherwise, they will be scared and they may not want to be interested. So as a result, so the adjustment can be done in this way. So meaning that expanding this as well as expanding this has the same meaning. So what I have here is the same thing as this. So this one is more or less of what? This one is synonymous to this. That is, what it simply means is the same thing as this. By the time we try to break everything I have inside this bracket down. So to continue with this thing now is to say that, and remember, since we are asked to expand this thing, it is important we know the coefficient for this thing under what? Under the construction of our Pascal triangle chart. So we know since it is square we are dealing with, right? So it's going to have combination 1, 2, and 1. That is, I can say 1, 1, and 1. So we know 1 will be here, 1 plus 1, 2. This is 1. So since this thing has the power of 2, it means we need this level. Remember, this is when the power is 0. This is used when the power is 1. Why this will be used since our power is 2. So to continue with this same means I'm considering the two simultaneously. So the two has to be considered simultaneously, and in the first instance, so this one will be written in such a way that it occupies the whole power, while this will not have any power. That is, it has a power of 0, and we'll continue that way until this one will not have what? A power of what? Of 0. So to doing that, I can express it as x raised to the power 0 multiplied by minus y, x raised to the power 2 multiplied by minus y raised to the power 0 plus, now then second way now, so is to say that what? X raised to the power 1 multiplied by minus y raised to the power 1, and finally x raised to the power 0 multiplied by minus y raised to the power 2. And we know that once the first item here has the power of 0 and the second item here has the total power I have here, that is the stopping point to my expansion. Then the rest now is I simplify what I have here so as to be able to what? To conclude. So doing that means there is still need for me to insert my coefficient. So it means the first term of our expansion here will go with this one. So that will be 1 into this. Why the second term of the expansion is this? So it goes with these two. So I will say 2 into this. And finally, last term of expansion goes with this one. So I can say 1 into what I have here. So when I simplify further, so I have 1 into x raised to power 2 remains as x raised to power 2 multiplied by, minus y raised to power 0 means a number raised to power of 0. And any number having the power of 0 automatically becomes what? 1. So that will be this times 1 plus 2 into, now x raised to power 1 here means x should be written once. So x raised to power 1 here gives the value of x multiplied by minus y raised to power 1 means we should write minus y once. And minus y is what I'm to write, so that will be minus y. Then plus 1 into this one here, I have x raised to power 0. That means anything raised by 0 is 1. That will be 1 multiplied by. And here as well, I have minus y raised to power 2. From basic laws of indices, minus y times minus y. Minus times minus here becomes plus. Y times y becomes y squared. Or I can simply write it as y squared. So minus y raised to power 2 here becomes y squared. And what follows this is what? I still have to complete my simplification. So that will be 1 into s squared times 1 here is s squared plus 2 into x times minus y gives minus xy plus 1 into 1 times y squared here gives what? Y squared, right? So 1 multiplied by s squared here, I have s squared. Now plus times minus, I have minus. Then 2 times xy, that will be 2xy, that is minus 2xy. Then plus 1 times y squared, that gives y squared. So this is the final result. So that shows that what? Expansion of x minus y raised to power 2 gives the value of what? S squared minus 2xy plus y squared. So we shortly I shall move over to another question because we want to get ourselves highly comfortable with dealing with this expansion before we now begin treating the Olympiad topics one by one, right? So let's quickly take note of this and copy it. So let's take another good question. So I have 2x minus 3y raised to power 3 is what we want to try this time around. Now, since I know I'm going to expand, so it's important before I begin dealing with this expansion to know what are those level of this Pascal triangle that will be of interest. So in that case, I easily can construct. So for now, let's still be constructing it so that we'll get used to it very well. So I will begin with 1, 1. Here we have 1, 2, 1. And finally, I have 1, 3, 3, 1. So since the expression given to me has the power of 3, so it shows this is the level of the triangle or the pattern of numbers that is going to be useful to what I want to do here. So we move over to this. So remember I said in the last question I solved that we want a situation whereby between the first element and second element, there is an addition sign there. But what if the question comes in a negative sign like this? How should else be treated? So we are going to treat it in that manner. Because the general assumption is addition is supposed to or exists between the first number as well as the second number here. So that one will take me to do what? To re-expressing what is here. So re-expressing it here becomes 2x plus. So the entire minus 3y I have here, I will now put it in what? A small bracket here. I can now say that everything is what? Raised to power 3. So that's the first thing. So it means what I have here as well as what I'm asked to do here means the same thing. So if we want to confirm how true that is, let's just try to open this mid bracket. So by the time we open this bracket, it will give the same result. So which shows that what? This and this is the same thing. So this is the only one that this is what will enable me to be able to apply those ones we started yesterday. So in order to do that, let me write this one here because the power is 3 is going to be a little bit complex so that the board can occupy it. So I don't want to model things up, so I prefer showing my workings here. So let me say I have 2x plus minus 3y, then everything raised to power 3, right? Now the next thing is we want to begin with the expansion. And by the way this thing works, right? It works by what? We begin at we want to create many terms. So every time we are considering those terms, it must be component of what? It must comprise of the first element in this bracket and the second element in this bracket, right? And the power, right? We are going to give to them. So start from with these 3. So whereby the first element here, take the whole power here, while no power is going to be given to this, and we'll continue dropping it that way until this one now has the power of what? Of 0. So to doing this now, so is to say that what I have here, 2x is raised to power 3 multiplied by, so this one initially will not have any power. That is, it will have a power of 0. So that will be multiplied by minus 3y, everything raised to power 0. Everything raised to power 0. So since I still have to write an equivalent term from that we obtain from our triangle, so it's better I now introduce a square bracket, right? Then the next thing is I will continue with the expansion until the first one has the power of 0 and the second one has what? Power of 3. So since I've not gotten to that level, so I will continue expanding. So the next expansion will be my square bracket as well. And you know, when we are doing it second time, so what will happen is the power here will reduce from 3 to 2, while the power here will increase from 0 to what? To 1. So that becomes 2x raised to power 2 multiplied by minus 3y raised to power 1. So that is the second time. Now the expansion will continue. For what reason? Because our target is situation whereby this first one I have here has the power of 0, and the second one I have here has the power of 0, and this one has the power of what? Power of 3. Since I've not gotten to the target, then that means the expansion will continue. So then plus, right? Now from having power of 2 to drop to what? Having power of 1. So this will now be written as 2x raised to power 1 multiplied by minus 3y. So once this one dropped value, this one will gain what this one has dropped. So from 1, this one increases to 2. Now at every point in time, it's important we always consider, are we done with the expansion, or is there any further chance of what? Of continuing with our expansion? And we know I made mention of the target the other time, that the target is to ensure the first element, right? The stopping point for this expansion will be a case or situation whereby this first element here has the power of 0, and the last element here has the power of what? Power of 3. And let's observe what we have here. So does this conform with that our target? So we can see we are not yet there. Since we are not yet there, that shows the expansion continues. So we expand it one more time. So let's say plus, right? Now we continue using the same reasoning. So what happened here is, So for me to continue now, it shows the power for this 2x will also drop by 1. So when this one reduces by 1 again, it now becomes what? 2x raised to the power 0. Then multiply by, now this one will now increase this to what? To 3. That will be minus 3y raised to the power 3. We also need to check so as to know whether we are done with the expansion or we are still going to continue. So and that's to recall what's the target of what we are doing. So the target is we want to start from here and continue expanding it until we get to a stage when the first item or the first element here has the power of 0 and the second element or the last element here has the highest power, that is the maximum power of 3 as given in this question which we have to solve. So I think this thing is in conformity to that target. So that shows we are done with the expansion. Now, having done with this expansion, the next thing is to simplify. But before we simplify this thing, now let's pick this our values from Pascal triangle and and fill it in the appropriate place. So we can see this is the first term of our expansion. It goes with this first number. So 1 will be here. Second term of expansion is 3. So it goes with the second term of the expansion. Third term of expansion is this. It also makes use of these 3. While the last one here is going to be this 1. So with this, we are going to do what? To simplify. So simplifying it here means 1 into. Now what this thing means is we should multiply 2x in 3 times. That is 2x should be repeated 3 times. So meaning of that is to say that 2x times 2x times 2x. So 2 times 2, 4, times 2, 8. There I have 8. So I still have x. So no, x times x is x squared. X squared times x, that will be x raised to the power 3. Or we count it, how many x do we have? 1, 2, 3. So that will be x to the power of what? Of 3. Remember, we are not adding, we are multiplying. So when we are multiplying, we'll be talking in terms of what? Of power. So that will be 8x raised to the power 3. Then multiply by, now here, what I have is minus 3y to the power of 0. And recall from basic laws of indices that anything having the power of 0 automatically becomes or changes to what? To 1. Therefore, minus 3y raised to the power 0 here is 1. So that will be multiplied by 1 plus 3 into, I can now switch over or move over to my second term. So in my second term, what I have is 2x to the power of 2. That one is an instruction that what? This thing should be repeated twice by way of what? Multiplication. So that means 2x times 2x. And we know that gives 2 times 2, 4, x times x, that is x squared. So meaning that what? Simplification of 2x squared becomes 4x squared. Then multiply by, so we can see what we have here is minus 3y, everything in this bracket raised to power 1. So what that means is the item in this bracket should be written just one time. So that means minus 3y raised to power 1 gives minus 3y. So that will be multiplied by minus 3y, then plus my 3 into, now here is 2x raised to the power 1, so which means 2x will be written once. So that becomes 2x multiplied by, and we can see here as well, we have minus 3y squared. That is the item I have in this bracket should be written 2 times. So by way of multiplication. So that becomes minus 3y times minus 3y. So we should observe what is going on here. Minus times minus here changes to plus. 3 times 3 here is 9. While y times y here becomes y squared. And we can as well write it as just what? 9y squared. So meaning result of opening this bracket becomes what? 9y squared. Then plus 1 into, the last one here. Alright, so this is 2x raised to the power 0. So remember, anything raised to the power 0 becomes 1. So this one is 1. There I have 1 multiplied by. And finally, I have minus 3y raised to the power 3. So what does that mean? It means this thing should be repeated how many times? 3 times. So that means I should rewrite or re-express my 3y 3 times. So that becomes minus 3y times minus 3y times minus 3y. Minus times minus plus times minus minus. That becomes minus. 3 times 3 here is 9. 9 times 3 here is 27. 27, y times y squared times y, that is y raised to power 3. So this gives minus 27y to the power of what? Raised to power 3. Okay, then the next thing is we continue simplifying till we will get rid of what? Of the bracket. So that means 1 into 8s cubed times 1. So that gives 8s cubed plus 3 into 4s squared times minus 3y. Yes. So we begin with number against number, then variable against variable, letter against the letter. 4 times 3 times minus 3 here gives minus 12. And now s squared times y gives s squared y plus 3 here into 2 times 9 here is 18. X times y, that is xy squared plus 1 into 1 times minus 27y squared. So that gives minus 27 cube rather, y raised to power 3. So to continue with this means we will open this bracket. So opening this means 1 times 8s cubed, that gives 8s cubed. Now plus times minus here, minus 3 times 12 here, that is 36 x squared y. Now 3 times 18 here, that gives 54 x y squared. Then plus times minus here gives minus 27y to the power of what? Of 3. So we can conclude this is it. But when we observe this mid term, so we have some items common. So in order to deal with we can leave it this way and we can as well progress a step further. So what we can do here is this. Now the 36 I have here, I can express it as 2. Okay, let me do it this way. 36 x squared y is what I have here. So if I'm to break this down, 2 in this one gives 18x squared y, 2 in 18, 9x squared y, 3 in 9, 3x squared y, 3 in 3, x squared y, and x, xy, x again, y, and y gives 1. So I can do the same thing for my 54xy squared. So 54xy squared here is, because we want to fish out for what is common to the two terms. So here can be what? 2 in 54, that is 27x y squared. 3 in 27, 9 sy squared. And 3 in 9, that is 3 sy squared. 3 in 3 gives xy squared. X in this, y squared. Y in this, y. And y in this, 1. Right? Now, what I want to do here is I want to pick what is common to these two terms. Right? So that can now be written as 8s cubed. Right? Now, let's see the term common today. I have 2 here. I have 2 here. 3 is here. 3 is here. 3 is here. 3 is here. That's that about number. Let's pick the letter x, x. So I didn't have x again, but y against y. So we just multiply those values together. So 2 times 3 here is 6. 6 times 3 here is 18. So that means we have minus 18. Now what about the letter xy, xy? 18xy. I can now open the bracket here. Abi? Now, what do I have left? In this first expression here, I'm left with 2x. So I can say 2x, right, minus, I can say 2x minus, then what do I have here left? That is 3 and y, minus 3y minus 27y cubed. So the result we have here is what? The solution to the expansion of 2x minus 3y raised to the power of 3. So let's try whether we can solve a few more questions before we also call it a day today. So it is important we have thorough knowledge and understanding of this, because in our Olympiad mathematics, just like I've said, we want to be dealing with some complex question. And one of the means by which we can approach a very complex question is by means of identity. And for anyone to be able to use identity, all those properties of identities as we have to get used to them. So before we can get to the state whereby we'll be used to those things, it's important we also know how we can deal with some basic expansion. But by the time we get to some um, very interesting aspect of this algebra, when we be talking of AMGM inequality, right? So there will also be need for us to carry out some expansion, and if the foundation to dealing with this expansion is weak or poor, so we have challenge then. And that's the major reason why most people usually say that mathematics is tough when it goes to the higher level. Not that it is tough there, it's only because we have not been able to be told to emphasize on basic items, basic concepts. And mathematics, according to some professional in the field of mathematics, mathematics is described as a journey. It is not even a course. They don't describe it as a course. They refer to it as a journey. So which means every step of such a journey has to be covered. When you skip a given or a particular step, automatically there is no shortcut to it. It will pose problem for one in later classes. So as a result, it's better we go step by step. It is better we go step by step. So let's ensure we understand this basic aspect very well. So when we get this basic aspect now, then moving to other advanced aspect of what we want to do becomes lively then. So as a result, I am begging the students to make sure they are able to deal with any form of expansion. Let's get used to it. Let's get used to it, and let's get used to it. So once we are able to manipulate all these things the way which we have done here, so we are going to realize that though the journey is tough, but I am promising you it is not. It is tough in the sense that you have to engage yourself in so much of workings, so much of the calculation. So that's the only sense by which I said the road to the exam which we are preparing for is tough, but by the content, once we understand the basis which we are doing now very well, so we realize that so there is nothing there, there is no big deal there. So shortly we also move over to another question. All right, let's take another question. X over 2 plus m. Let's say it is raised to power 3. So, and I believe by now we should be used to Pascal triangle involving the power of 3. But if we're still not being able to know what the structure, the pattern of line 4 of our Pascal triangle is, it is not a big deal to construct it. But in order to save the time, so I will just write 1, 3, 3, 1. This is for my own case, but for the students that are just learning this thing, so it is better you compute down your Pascal triangle so as to detect what exactly do we need when we get to when we want to do to expand a given expression to the power of 3. All right, so to continue with this thing, so we can see this thing conform with the usual standard. And what is the usual standard? The usual standard is in between the first element as well as the second element, we want to see what there, an addition sign. So once an addition sign is there, then we can progress to expanding. In this case, there will be no need for adjustment. There will be no need for any form of adjustment. All right, so let's begin. So to do this, and remember the way by which this thing work. It work by what? We are going to give this entire power to the first element first. While the second element will have no power, that is, it will have the power of 0. We continue like that until this first item or this first element now has no power, and this last one here has this entire power. And after we've done that, we are going to simplify. So after the simplification, then we can present our answer. So to continue now is to say that what? The first item I have here, raised to power 3 times the second item here, right? So to be better, I use a square bracket. So I will combine it with the, okay, this is raised to power 0. I will combine it with the next item. So the next item here is a case whereby this power here dropped by 1. So that becomes x over 2 raised to power 2 multiplied by m raised to power 1. So this continue. Why do we know it's going to continue? It will continue because the power of this first element or this first item here is not yet 0. We continue until the power is 0. So that becomes x over 2 now raised to power 1 multiplied by m raised to power 2. And finally, so I have x over 2 raised to power 0 multiplied by m raised to power 3. And remember, we are not, our expansion is not yet complete. It is still missing one certain ingredient. And what is that ingredient? That is the pattern which we observe from the level 4 of what? Of our Pascal triangle. And that simply is the 1, 3, 3, 1. All right, so the first term here goes with the first item we have in that pattern. Why the second term, pick these 3. Third term, pick these 3. The last term we what? Go with the one which I have there. Now let me remove this so as not to create unnecessary confusion. So the rest is, we only want to simplify. After the simplification, we can present our answer. So we say the result here is 1 into, now here I have x over 2 in 3 places. So it means x over 2 times x over 2 times x over 2. And we can see x times x times x. That gives x raised to power 3. 2 times 2, 4 times 2, 8. So x over 2 raised to power 3 here becomes x raised to power 3 over 8. Multiplied by, you can see m raised to power 0 here gives 1, because anything to the power of 0 becomes 1. Then we continue by expanding x over 2 squared. So x over 2 squared means x over 2 should be repeated twice by way of what? Multiplying. So s times s here is s squared. 2 times 2 here gives 4. So it means s squared over 2. S over 2 squared here is s squared over 4 multiplied by m raised to power 1 is an instruction to write m once. So multiply by m plus 3 into x over 2 raised to power 1 means we should write it once. X over 2, yes, and that is everything. So I will say x over 2 multiplied by m squared plus 1 into, so remember, x over 2 raised to 0. Any number at all, once it has the power of 0, automatically becomes what? 1 multiplied by what? M cubed. So the result here becomes 1 into, this times 1 gives x raised to power 3 over 8 plus 3 into, when this is done, so let me do it in a stepwise manner. What I want to multiply there is s squared over 4 multiplied by m. I can as well write this m as m over 1 so as for it to be in fractional form because of this first one. Now, I can now multiply s squared times m. I can write it as s squared m, or I as well can write it as ms squared. It is the same thing. Then 4 times 1 here gives 4. So here I have s squared m over 4. Then plus 3 into x over 2 times m squared. That one can be written as x over 2 times m squared over 1. So when the multiplication is done, I have x m squared, everything here, over 2, then plus now plus 1 times m raised to the power 3, 1 into m raised to the power 3. Now the next is I can do it this way. 1 multiplied by this, or before I open these brackets. So let's try and observe that there are some common terms here. So I want to remove those common terms first. Oh, no problem. Let us continue. Now, when we multiply this one, I have s cubed over 8 plus, if this multiplication is done, right? Don't worry, we are starter. So let me do it the way a starter is to be taught, right? So I want to open these brackets. That is, I want to simplify what I have here. So this stuff here is the same thing as 3 over 1 times s squared m over 4. I hope that is taken. Now, we multiply the numerator, we multiply the denominator. So that I want us to get it fully from the scratch now. So that by the time it gets to the complex aspects, remember I've told you, everything we are going to meet in this our short course or this our short training is not difficult, right? The only person that will take it to be difficult is the one who has a foundational problem. And in order for you not to have the foundational problem, it was my reason for repeating all these aspects. So let me repeat this one as many times as possible. So now 3 multiplied by this can be rewritten as 3 over 1 times s squared m over 4. Now what follows? So I'll multiply now. Now 3 times s squared m, that gives 3s squared m over 1 times 4 here gives 4. Now plus 3, no. Let me also open that bracket. So 3 there becomes 3 over 1 times xm squared over 2. Remember, the reason why I changes this my 3 to 3 over 1 is because I'm trying to multiply a whole number by a fractional number. And if such is to be done, and for us to avoid any confusion, it will be better we also express that whole number as a fraction, since every whole number can as well be written in fractional form. All right, so when this is multiplied now, the result I have now is 3xm squared, everything over 2, then plus m raised to power 3. So I can say that we are done, but we are not totally done, in the sense that this midterm here, we want to check, we want to factorize this midterm. So if there is anything common to them, we separate it from those things not common to them. So once we are able to do that, then we fully satisfy the requirements of the question which we have to solve. All right, here I have 3s squared m. So I can do it this way. This is 1 over 2 times 1 over 2 times 3 times x times x times m. So the other one here, so this, you can see this number is denominator. And the reason why I use this 4 as 1 over 2 times 1 over 2 is because I have divided by 2 here. You know, anything divided by 2, we can as well say over 2. For instance, if I have k over 2, it is the same thing as 1 over 2 times k. Definitely, if I have k over 6, it is the same thing as 1 over 6 times k. In fact, this 1 over 6 too, I as well can write it as 1 over 2 times 1 over 3 times k, and if you want, you can say over 1 in this case. So because I have 1 over 2 here, I have 1 over 4 here, so this one prompts me to what? Convert this 4 to 2 times 2. And since it appears as a denominator, so it is written as there is something above it. And once I'm separating this denominator from the numerator, so that shows I'm going to give it its own natural or its own personal numerator, which is going to be 1. So that's my reason for saying 1 over 2 times 1 over 2, the way this one is. Then also here, I can write that one as 1 over 2 times 3 times x times m times m. The essence for doing this is I want to factorize, that is, I want to fish out the common term to this and this. Right, now let's pick those things that is present here as well as here. We can see 1 over 2 is here, 3 is here, x is here, m is here. That's all about what is common. So we can progress by saying what we are doing here is equal to x raised to the power 3 over 8, x raised to the power 3 over 8 plus, all right, so what is common now? What we have as common is 1 over 2 times 3, that is 3 over 2, then xm. So 3xm over 2 into, what do we have left? This one here, we are still having 1 over 2 and x. So here I can say 1 over 2x or x over 2. So between them is addition. I will say plus. So what do I have here left? Is only m. So x over 2 plus what? Plus m. X over 2 plus m. So I want to rub this short stuff I did. So I know this one is JSS2 stuff when it comes to factorizing, but we have to remind one another so as to what? Make this our journey an easy one, right? So I will conclude my answer now and we are going to call it a day. Then we say plus m raised to the power 3. So the result I have here is the expansion of s plus 2 plus m raised to the power 3. So this is it for today. So I'm not making it too much for now, so that I want us to comprehend this thing fully. So one, we have full grasp of all these things which we have done. It will assist a lot in 3 other aspects of the mathematics which we want to cover here, just like I said the other time, and that only the geometry aspect of it that will not rely on some basic concepts in algebra. So all these things we are doing now, so should what? Be learned thoroughly. So because when you understand it properly now, it's going to what? Be of assistance. So well, I don't have to talk too much about it now. And when we progress to all those areas of mathematics that this thing will be useful, so you are going to come back here and appreciate me for making sure that what we have a very solid foundation here. So that is it for today.